Hey everyone, and welcome back to the show. Today we're diving deep into something that might seem a little, well, elementary at first glance.
Yeah.
Shapes.
But trust me, there's a whole lot more to shapes than meets the eye. We're going to uncover the hidden beauty and complexity of these fundamental building blocks.
Okay, hidden beauty in shapes.
Mm-hmm.
You definitely piqued my interest. I sent over a chapter from an elementary shapes book. I'm ready to have my mind blown.
Oh, we can definitely do that. This isn't just about memorizing what a triangle is. It's about understanding how these basic forms underpin, well, practically everything around us. Architecture, art, music, you name it. It all comes back to shapes in some way.
I'm ready to be amazed. So the chapter starts off with a humble line segment, describing it as a fixed portion of a line. Remind me again why that's so important.
Because that fixed length is what allows for measurement. I mean, you can't really measure something that's constantly in flux, right? That fixed portion concept is key because it lets us compare, analyze, and ultimately build with lines.
That makes a lot of sense. And speaking of figuring out those lengths, the expert talks about observation, tracing, and then, of course, there's the good old-fashioned ruler.
And those methods really illustrate the evolution towards greater accuracy in measurement, don't they? Our eyes can be easily tricked, tracing can be inconsistent, but a ruler, that gives us a standardized unit of measurement, taking out the guesswork.
Yeah, it's like the difference between trying to bake a cake by eyeballing the ingredients versus actually using measuring cups and spoons. One is probably going to be a delicious disaster.
Exactly. And that need for precision, it's everywhere. Can you imagine a surgeon during an operation just estimating distances? Or an architect designing a skyscraper based on a rough sketch? Chaos.
Point taken. So lines are like the backbone, but what about angles? Those have always seemed a bit trickier to wrap my head around.
Well, think of it this way. Angles are all about the relationship between those lines. Let's see something we all know. A clock face. That full rotation of the minute hand, going from 12 all the way around back to 12, that's what we call a revolution. A complete angle, 360 degrees.
Oh, okay. And half of that, like if you were going from, say, north to south on a compass, that would...
A straight angle,
Yeah.
Precisely. And then there's the right angle, that perfect corner, like on a square, which comes out to 90 degrees. And from there, we branch out to acute angles, which are smaller than a right angle, and obtuse angles, which are larger.
Right, right. And the book even mentioned using a carpenter's square as a way to test for those right angles. You know, reminding me of those little right angle testers we used to make in school. It's amazing how a hands-on activity can really make a concept click, isn't it?
Absolutely. Although, for real accuracy, we turn to the protractor.
Yeah.
But it is fascinating. That idea of a circle being divided into 360 degrees, that system of measurement actually goes all the way back to ancient Babylon. They looked at the cyclical nature of the heavens and, well, the rest is history.
Wow. Talk about a deep dive. Okay, so we've covered lines and angles, so does that mean we're ready to start building some shapes?
Let's do it. Let's start with the simplest polygon, the triangle. It might seem basic, but trust me, there's a surprising amount of variation within those three sides.
Oh yeah, with triangles, we've got the scalene triangle where all the sides are different lengths, then the isosceles with two sides the same.
And of course, the equilateral where all three sides are equal. But here's where things get really interesting. See, a triangle's type isn't just about its sides, it's also determined by its angle. So you could have like an acute triangle where all the angles are less than 90 degrees.
Which, now that you mention it, you couldn't have an equilateral triangle that also has an obtuse angle, could you? Because then, wouldn't that mean at least two of the sides would have to be different lengths? It's like the book said, some combinations just aren't possible.
You're absolutely right. And that inherent relationship between a triangle's side lengths and its angles, that's the very foundation for so much of geometry and its real-world applications, too. It's about understanding these properties that make shapes strong and give them stability.
Okay, now I'm starting to see how all of this goes way beyond just basic shapes on a piece of paper
Yeah.
and gets into like building design and architecture.
Exactly. Think about bridges, for example. Those triangular structures you often see supporting them, well, that's not just an aesthetic choice. Triangles are inherently strong because of how their shape distributes weight so evenly.
So triangles are all about strength. What about quadrilaterals? You know those four-sided figures?
Yeah.
The book mentioned a whole bunch. Parallelograms, rectangles, squares, rhombuses. It's a mouthful.
It is a lot to keep track of, and each of them has its own unique characteristics, of course. Parallelograms, they have those opposite sides that are parallel, and that gives them some very interesting properties, especially when you start putting a bunch of them together. Then you've got rectangles. They take it a step further with those all-important right angles, which, as you can imagine, makes them ideal for construction and design.
And a square is basically just a special rectangle, right, where all the sides are equal.
Precisely. And then you've got rhombuses. Think of them like squares that got a little squished. So they still have those equal sides, but they don't necessarily have the right angles. And of course, let's not forget about the trapezium, which is often overlooked, but important in its own right, with only one pair of parallel sides.
Well, I'm already starting to see these shapes everywhere I look. Okay, so we've gone from lines to angles to these flat shapes, but I have a feeling things are about to get even more interesting when we start talking about three-dimensional shapes.
Ah, yes, the 3D world. This is where those abstract concepts we've been discussing start to take on a more concrete form. Instead of just lines and angles on paper, we're talking about objects that have volume, objects that take up space in the world.
Exactly. It's like instead of just drawing a square, now we're talking about an actual box.
Yep.
Or a pyramid or a sphere. That is so cool.
It is. And with 3D shapes come new properties to consider, things like faces, edges, and vertices. Take the cube, for example, which the book uses to illustrate this. A cube has 6 square bases, 12 edges where those faces meet, and 8 vertices, which are those corner points where the edges all come together.
So it's like each 3D shape has its own unique fingerprint based on those elements. Okay, a cube is pretty straightforward, but what about a prism? The book mentioned that they're used in things like periscopes, which sounds way more complex.
It all comes down to understanding a shape's fundamental properties. You see, a prism, by definition, has 2 identical bases, and then all those other faces are always going to be rectangles. The thing is, the shape of those bases can vary. So you could have a rectangular prism, like a cereal box where the bases are rectangles. But then a triangular prism, which is a kind often used in periscopes, has 2 triangles as its bases.
So that's how they bend the light. The light goes in through one of those triangles, bounces off the angled sides, and then exits through the other triangle on the other side. That's incredible. It lets you see around corners.
Quite clever, isn't it? And then you have pyramids, like the iconic Great Pyramid of Giza. A pyramid has to have that one base, but it can be any polygon. And then those triangular faces that all meet at that top point, which creates a remarkably strong and stable structure.
And those triangular faces are key, right? Like we were saying before about how strong triangles are. It's like those ancient Egyptians were masters of geometry.
They definitely knew a thing or two about the power of shapes. But remember, pyramids don't always have to have a square base. Imagine a triangular pyramid where the base is a triangle, or even a hexagonal pyramid with a hexagon as its base. The possibilities are almost endless.
My mind is officially blown. And those are just the shapes with all those flat surfaces and edges. What about the round ones, like cylinders, cones, and spheres? Those always seemed way harder to wrap my head around.
They do have a different kind of elegance, don't they? Cylinders, for example. They've got those 2 identical circular bases and then that curved surface connecting them. Think of a soup pan. Perfect example.
Okay, I can picture that. So 2 circles and then that wraparound part that would be the label. And then cones are like
ice cream cones.
Yeah.
Exactly. They have that one circular base and then that curved surface that tapers to a point at the top. And then, of course, there's the sphere, which is probably the most symmetrical shape of them all.
Like spheres are the rebels of the shape world, right?
Mm.
No edges, no corners, just pure roundness.
Precisely. With a sphere, every single point on its surface is exactly the same distance from the center. It's a shape that we see all the time in nature. From planets to bubbles, it's everywhere.
So we've gone from those simple line segments all the way to the planets and stars. Who knew a deep dive into shapes could be so expansive? It really is amazing. It's like we've unlocked this secret code to understanding the world around us. And, the chapter really emphasized how crucial it is to understand these properties of 3D shapes, especially when it comes to things like engineering and design. Like you were saying before with the pyramids, their shape wasn't just about aesthetics.
Exactly. It all comes down to function following form. Architects and engineers, they rely on these fundamental geometric principles to create everything from those towering skyscrapers that can withstand incredible forces like hurricane winds to those massive bridges that span huge distances. The strength of a structure, its ability to support weight and resist all those external forces, it ultimately boils down to the shapes that are used in its design.
Oh, totally. It's like choosing the right tool for the job. But instead of hammers and saws, we're talking about like cones and cylinders and...
Exactly. And it's not just about the individual shapes themselves. It's also about understanding how those shapes interact and work together. Think about arches, for example. They're used all the time in architecture to create these openings like doorways and windows. And even though they might look delicate, The curved shape of an arch is incredibly strong because of how effectively it distributes weight outward.
Which is probably why all those ancient Roman aqueducts are still standing after all these centuries. It's incredible what they were able to achieve without, modern tools and technology.
It really is a testament to their deep understanding of geometric principles. And it goes beyond just strength and stability, too. Shapes play a huge role in design aesthetics. Artists, for example, they use shapes in very deliberate ways to create these visually appealing compositions. They play with things like symmetry and asymmetry, curves, angles, all to evoke specific emotions and ideas. That's so true. I never even thought about it like that before. Like a circular sculpture is going to give you a totally different feeling than a sculpture that's made up of these sharp, angular shapes, right? It's like even in the everyday objects around us, the shapes that we surround ourselves with can have this really powerful, even if it's subtle, impact on us. It can affect our mood, our well-being.
Absolutely. Think about the furniture you have in your home, even the dishes you use every day, the design of your car. Shapes are everywhere, and they can subtly influence our perceptions and experiences in ways that we might not even consciously realize.
It's like we've been living in this world of shapes without truly seeing them. This deep dive has been a real eye-opener.
It really is all about shifting your perspective. Once you start paying attention to the shapes that surround you, I think you'll be amazed by just how much you've been missing. I know I am. So, to wrap up our deep dive into the world of shapes, I want to leave our listeners with this one thought. Next time you're out and about, take a moment to really look at the shapes that make up your surroundings. Notice those arches over doorways, the cylindrical columns that are holding up a building, or the triangular trusses supporting a roof. Think about why those specific shapes were chosen and how they all work together to create these structures and objects that we often take for granted. I think you might be surprised by what you discover.
It's true, it's a world of hidden geometry just waiting to be explored.
Absolutely. And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us on this geometric journey, and we'll see you next time for another deep dive.